Stevie, you are on SkepTalk with Dr. Adair and Erika. It says here, our screener says that you want to talk a little bit about molecular machines. Do you want to get into that a little bit with us? Tell us a little bit more about your perspective and what you're here to make a case for today.
Yeah, absolutely. It's great to meet you guys, by the way, Erika, Aaron. Great to meet you guys. I didn't see the debate you were talking about earlier, but I did see a debate you had with another gentleman, kind of older gentleman, and I will say, he wasn't too lively. That's all I can say.
Stevie, it wouldn't be the first time that's happened. I've had the pleasure to get a few with younger guys. You could put that you could clip chimp that in a lot of ways. But a lot of these professional creationists have been doing this racket for quite some time, and so as a result, the ones that are willing to actually have these kinds of conversations tend to be on the older side of things. But I think that for your question today, which you brought up in the chat, that's a little bit different than the debate that I most recently had, but I certainly think that I can weigh in a little bit on it. So tell us about molecular machines.
Yeah, I'm excited to get your take. So, so I think this is a relatively strong argument, and we'll see what you have to say about it. But there is a molecular machine by the name of repliposome. Have you heard of that one?
Yep.
Okay, repliposome is the molecular machine responsible for the replication of DNA. Of course, this is an incredibly complex molecular machine, has a lot of different parts to it, a lot of features. It's just to hit on some things I thought was super interesting with it is, it works at a high speed. It's basically an AT powered motor capable of replicating, I think it's 1,000 nucleotides per second. Something else really interesting with it is that it actually has like an autocorrect feature to it. It actually can go back and correct, if there was a mistake, it can actually move backwards and whatnot. So, but the reason why I think it's such a strong argument is that DNA cannot replicate without this molecular machine. And so you really have to have this machine before you can have DNA. As I'm sure a organism without the ability to replicate its DNA will not last very long. And I think this argument is particularly powerful because even the simplest, most basic organism, a single cell, has DNA, which means it has this molecular machine. And without this molecular machine, you don't have that. So basically, the crux of the argument is this. Number one, I do think it is irreducibly complex. Number two, you have to have this before the first cell even appears. And then not only that, but the actual machine itself is made from proteins, which is also has to be coded. You get that from DNA. So they both have to basically come into existence at the same time, my understanding. Either that or the machine had to come first, but the machine couldn't come first because it has protein. So that's kind of the opening line that I wanted to throw out there. So far, what do you think?
Yeah, I mean, this is super boilerplate with regard to conceptually, right? So this idea of irreducible complexity, for those in the audience who might not know, is this idea that you have some biological systems or biochemical systems which are so complex that you couldn't get there by means of typical evolutionary processes where each step in and of itself is performing that task up until it reaches its sort of most advanced form. And if you take any part away, then the system fails. And so it therefore couldn't have evolved. That's like the super down and dirty sort of explanation of what irreducible complexity is. And typical responses to irreducible complexity as an argument is the fact that every biochemical system or biological system that we know of actually can be broken down into smaller parts. They just don't do the same function that the final current form does, right? So classically, people have brought up like the bacterial flagellum, and the idea is that, well, the bacterial flagellum is effectively kind of like a motor, and so how do you actually get all of the parts in the right place at the right time to confer this flagellar activity to the organism? But it turns out that you can actually take pieces away from the bacterial flagellum from its motor system and get what is effectively like a syringe. So it's a different structure that performs a different function that is in and of itself useful to the bacteria in question. It's the classic sort of counter to irreducible complexity. And when we're talking about something like DNA replication, right? DNA replication is actually like super, super sloppy. The replicasome, I've looked it up to make sure I was thinking of the same thing and not misconstruing anything, because biochemistry and genetics are not my like formal background, right? Like I teach basic DNA replication and protein synthesis as a part of biological anthropology, but I don't really, with my students, get much more in depth than that. But fortunately, the replicasome seems to just be another word for DNA replication, right? It's the process of DNA replication. It's a word that we use to sort of refer to the whole of it. And DNA replication is super messy, right? And it often doesn't work. It doesn't catch all of the errors in DNA replication in the process before actually you've got two daughter molecules. It's like a semi-conservative process where the DNA unzips and then you have the blanks filled in on either side, and you end up with two identical daughter molecules. The very fact that we get these enormous like mutations slip their way through this process and end up in the daughter molecules, I think, is support that this is a pretty rigged system. And it oftentimes misses like a lot of errors that have occurred that have accrued in the course of replicating the actual DNA strands themselves. But in addition to that, there's no reason to suppose that the DNA replication can't be more simplistic. In fact, if memory serves, it actually is more simplistic of a process in many organisms than it is just in humans. I'm going to try to find some examples of that just so I have something to kind of give you so you can dig into this a little bit more if you'd like. But Dr. Adair, do you have anything to add to what I've said so far, irreducible complexity-wise?
It is probably worth noting that when the arguments about irreducible complexity come up, they will look at modern versions of a thing and think that if you basically mess with the modern version, it can't possibly work, therefore it can't have any sort of evolutionary past. Where often it has like some long history of scaffolding where the scaffolding of its history is now gone and the simplified stripped down version is there. In the same way, if you look at a building, it's like, well, there's no way you could have piled up that giant pile of stones and it would have held up in place. And it's like, yeah, you're right. That's why there was scaffolding there. And we don't use it anymore because we think it looks ugly. I think a lot of, I don't know the details very well, but my understanding is that there's a lot of evidence that that's the kind of evolutionary history you have with a lot of structures. And just doing some really quick Googling, because this is not an area that I know very well, but apparently the molecule in question we're talking about here, there is more than one version of replicasome. That there's a bacteria version and there's a more eukaryotic version, and yet they're both working on DNA, which to me says like, hey, if this is created, why have two different versions of the same molecule to do the same job? This sounds like two different evolutionary histories to try to achieve the same result, which to me screams, oh, it can't be irreducibly complex if there's more than one variant trying to do the same thing, and they just took different paths to get there.
Yeah,
Stevie,
I think.
how does that
I'm sorry, I
sound
didn't
so
want to
far?
interrupt you.
No, sorry. I was trying to like segue into knocking it your way while I'm pulling up a paper here that I think might be of use to you. How does that sound so far?
Well, I know this isn't something. This is, I have a huge amount of respect for you guys because you put yourself out here and you don't know what the person's going to say, and so like I have a lot of respect for that. Yeah, I mean, I think that I think there's a couple issues with kind of the idea. I know that you guys tackled it only from the irreducibly complex frame, but I do think that there are some issues with that. But to me, that's not really the big heavy hitter with this thing. I think it's more about the fact that number one, there's no time for the evolution that we see, with the remainder, because the simplest cell has the DNA and has this molecular machine. There's no time for evolution to occur, down all those, time from the beginning of the first cell. But the biggest issue with this is the fact that you have to have both. You have to have both the replicasome and DNA come about at the same time. How do you guys handle, that kind of paradox?
Oh, just Erika, you're going to know more about this than me, but my understanding is the earliest forms of life didn't have DNA, but they used RNA for the encoding and the storage of genetic information. DNA then comes along later because it's a more stable molecule for doing that same sort of thing. I do not know the evidence about how that transition happened or where the state of the art is, but that's my basic understanding. We went from DNA, which we know can form completely naturally. It doesn't need extra machines around to do that, but DNA is then a later improvement on the process. That's my basic understanding. Erika, you're muted. Or at least extremely quiet otherwise.
Sorry, I muted a minute ago because my dogs were barking, and so it ends up being a mess. Yeah, my understanding from Origin of Life research is that RNA world is still like pretty ahead of everything else. I think people can bust my chops on that in the comments if they'd like. But in that sense, yes, I mean, RNA does and can self-organize, right? Like this is something that we've seen. The classic example people give is that it's capable of self-organizing on like clay as a substrate or wet dry cycles and things of that nature. And it's way less stable than DNA, right? Because it's single-stranded. RNA is a single-stranded molecule as compared to the classic double helix that DNA is. And my understanding as well is that RNA is what's sort of setting the stage for DNA. So like in that sense, DNA itself, right, isn't irreducibly complex either. Now you're talking about these molecular machines and saying, DNA has to come about at the same time as the replicasome, which is like the concept of DNA replication. These two things have to come about at the same place at the same time, but they don't. And no one is proposing that they show up whole cloth. Right, these intermediary steps between RNA and RNA replication, eventually through natural selection, because once things are alive, as so long as you've got RNA replication and organisms reproducing with variation for natural selection to then select upon, it's not actually that difficult to go from RNA to DNA, right? I think a much harder step, if you're going to take the perspective of like these large gaps in evolutionary history, would be, going from like, I guess, chemistry to life in the first place, or like prokaryotes to eukaryotes. But my understanding is that, and again, I'm not a biochemist. My understanding is that it's not that mysterious of a pathway. Does that make sense? Like no one's proposing that you just through chance got these molecular machines and to DNA to self-organize. Instead, the proposition is that you get self-organization through natural processes, which we know that happens, right? In something like an RNA molecule. Protocells are super simple. And over time, now that you've got things that are actually alive that natural selection can act upon, you see the emergence of more complex systems. Eventually, that's going to get you towards basic DNA replication. But, as Dr. Adair was saying earlier, and I was trying to do some quick Google searching as well, because this is not my forte, but we do have, there are more basic DNA replication systems that we know of today, not just the ones that are used in like, advanced mammals like humans. Does that make sense?
I think there's no, I hear your perspective. I mean, I think, and I am familiar with the RNA argument. There are a couple problems with that. Number one, I don't think we've ever, and you can correct me if I'm wrong, but I'm pretty sure we've never actually observed RNA come about by itself, only in a lab. And in the lab, the RNA that they were able to put together wasn't able to self-replicate. So it kind of had some limitations there. The other issue with the RNA world hypothesis is that there's no evidence for it. I'm sure you would both agree. Can you think of a single organism that's RNA based and has no DNA?
Well, hold on. I want to take that back for a second, because you said there's no evidence for it, and then you said that after it's been shown to happen in a lab, right? Like those two things can't exist at the same time. Because if you can show that RNA can self-organize in a lab, right? And my understanding is that it isn't just in a lab that this has been supported, but I'm going to try to pull something up so I can cite my sources here in a second. But if you can show that this can happen in a lab, like why is this suddenly impossible for it to happen in a natural context? I mean, the only reason we don't see, I would propose, the only reason that we don't see abiogenesis occur in the modern age is just because even if it happened, it would instantly be outcompeted by organisms that have been fine-tuned by natural selection and evolution over 3.8 billion years. There would be no way for it to actually take hold. But can you elaborate a little bit on that? Like when you say there's no evidence for RNA world, what do you mean?
Well, what I mean is that there's no evidence of an organism which is RNA based without DNA. Meaning, there's every organism, down to a single cell, has DNA. There's no other organism that has RNA, but only. The other thing
I
is,
think
you
one exception,
mentioned,
though, would be viruses, but then we probably could get arguing there a bit. But like retroviruses are completely RNA based; they don't have DNA.
Well,
yes,
and to
that's
that point,
correct. Yeah.
but to that point, right? Like life in general has, I think it's something like 8 characteristics that something has to be considered alive, right? Viruses meet some of those criteria, and they don't meet all of those criteria. So if you were to have or propose a transitional organism or sort of organism adjacent thing, right, that links non-living chemistry to bona fide life, would you propose that it would look something like a virus? Because I might. And boy, then isn't it all of a sudden like really coincidental and interesting that these sort of transitional steps between non-living chemistry and living things that we accept, like sensu stricto, use RNA and are the only ones that seem to do that? Wouldn't that be exactly what you would predict if life had emerged from an RNA world scenario?
I mean, I could see that argument. Like I said, I don't think there's much evidence for that. Viruses can't really do anything on their own. They're heavily dependent on the host. The other issue,
Well, you can say the same thing for me, though. I can't do much on my own, believe me.
right? The other issue you brought up was the fact that it was done in a lab. But like I said, in those lab experiments, they weren't able to. The RNA that they built was not able to self-replicate. So it's far less. In other words, the real RNA is far superior to that RNA, and that was being crafted by intelligent humans. And it doesn't even compare,
Right.
which is
But
Well,
it
actually, we
wasn't.
should be a bit careful
Yeah.
here. We should not say that they're not being crafted by humans. Humans are setting up experiments to say, we think this scenario is a regional analog to what we think an early
Right.
environment was. It is
No,
not us actually like using a printer. We've done that sort of thing. Like, what is it? Craig Venter in his lab has basically made artificial DNA strands and put them into living things and actually have them work. That's a different thing than, putting the chemicals together, setting an environment that's supposed to be some analog for early conditions on Earth. We should compare that, setting up an experiment to be like what we think something was analogous to in the past versus trying to assemble them molecule by molecule with some sort of directed mechanism like a printer.
correct. Yeah, I'm sorry if I made it sound that way. You're right. Yeah, but in a lab, they're able to control the environment and all that good stuff. But yeah, the biggest issue I find is that there there's just no evidence. Like there's no evidence that
Well,
you could point to. You know what I mean?
well,
There's
Stevie,
nothing
though,
observed. In other words,
yeah, I think you just described it though, right? Like in science, you generally have a hypothesis, right? Where it's like, okay, the origin of life probably emerged, in this RNA world, right? Under the sort of assumptions that we make about a world where RNA comes initially and then you get life from that. Um, that sets up a series of like testable predictions, right? That you can then carry out in a lab, right? There's nowhere on Earth today that you're going to be able to go to in the wild to see the conditions of Earth 3.8 billion years ago, right? Everything from the thinness of the atmosphere to the composition of the water is going to be different. So that's why these things are carried out in the lab. It's not because they're trying to control every aspect of the experiment, although that is nice so that you can isolate really what's going on and when it's going on. But the reason is primarily because we're trying to recreate an environment that isn't there anymore. So it has to be done in a lab. The conditions are engineered, but they're not engineered to be pristine. They're engineered to mirror natural conditions that we are building a model upon based off of like geochemical signals that are dated to like 3.8 billion years ago. That's why that's going on in a lab. So I would propose that if you create an environment in a lab that mimics, toward the best of our understanding, the environment in like a warm little pond or a hydrothermal vent 3.8 billion years ago, and then you end up getting self-organizing RNA molecules, right? I think that's a pretty awesome step towards understanding the origin of life, right? Now, I'm not going to sit here and tell you the origin of life is solved, because it isn't. People are working on it, right? That's the entire field of origin of life research exists to investigate just that. But even with the origin of life completely, like, still being worked upon right now, that doesn't have any bearing on the reality of, like, the ancient age of the earth and evolutionary theory being responsible for all modern biodiversity. And it really doesn't have any bearing on this question of, like, theism either, at least as far as I'm concerned, because there doesn't exist any preclusionary data for abiogenesis. It's just there's a myriad of different hypotheses to try to explain how it happened, and we're trying to figure out which one is most likely. And we've only been working on it for, like, I don't know, 60 years or something like that. I don't know how old the origin of life research is. I don't find that to be very compelling. Like, it's an origin in the biz when it comes to debating creationists. We call that kind of argument origins or bust, which it's basically like, well, if you can't explain how life emerged, then you can't really say anything about anything. And I don't find that to be particularly compelling. But I also want to point out that, we started with this idea of molecular machines and this idea that these molecular machines are highly complex and irreducibly complex. And Dr. Adair, and I talked about how, well, actually you can break them down. And that's how we ended up talking about, like, RNA and RNA world. And then that's how we got to abiogenesis. So I do think we've kind of moved the conversation, and that's okay. But, I don't think that I don't really find it to be very problematic. Like, I don't think an open question in science is very problematic to, like, this question of theism or not, if that makes sense.
Yeah, I mean, the whole point of this is just that they both had to come about at the same time, which is just not going to happen in nature. Both DNA and the replosome. The issue with RNA, like I said, is I know that we have a hypothesis and whatnot, but the biggest issue that I have is there's just no evidence. There's just no evidence. Like, you can't point me to
Stevie, let me try something when it comes to you saying that there's no evidence, because when we're talking about a hypothesis in science, we can talk about some hypotheses being better because of things that they can explain. What is the explanatory power of this hypothesis, especially compared to any other ones? So for whatever reason, I think it's most powerful to talk about, like, a forensic murder case sort of thing. So imagine the police get to a house. They find that there's no signs that the house has been broken into. Inside one of the rooms that had a lock, the room is unlocked and the murder victim is found there. Now, the fact that the place was a home, and yet it didn't seem to be, that room didn't seem to be locked, yet it seems like if someone is in that room and looked like they were trying to escape, it seems like they would lock the door behind them. So one of the things we might conclude is the person who got in was able to unlock the door, which tells you, hey, they must have had the key. That already, like, limits the number of suspects you might be considering. So instead of, let's say this murder happened in Oregon, you limit it from, instead of the entire state of Oregon, to, okay, people would have had keys to this room, probably then family or maybe a neighbor at most. So even if you don't have, evidence of who did it specifically, suddenly you've limited your possible search space drastically just from those inferences from circumstantial evidence. Add a few more circumstances and combine them together, you might be able to make a strong case that there's only one person capable of doing said murder. I think we're trying to do the same sort of thing here. There's, at best, and again, this is me speaking out of ignorance, RNA seems to be able to explain a whole bunch of different features, and other competitors aren't able to do the same. And again, an expert in abiogenesis can probably speak much more to how peptides might have been involved in that, because this is way outside my knowledge base. But that's the general analog. We use circumstantial data to limit the suspects until we say, here's the one that seems to explain the most evidence. And at the very least, why we should say RNA is the most likely to be guilty.
Well, and I think I'm going to add to that too, that, like, saying, because I've got a big problem with this idea of, like, well, these two things had to emerge at the same time, because I've heard that kind of argument a lot in creationism, whether it's talking about, males and females, the male and female sexes had to arrive at the same time, or how do you get the circulatory system arrive at the same time as the skeletal system? And, like, that kind of argument always fails because precursors always exist. Right? Like, we just talked about a precursor to DNA replication in the form of RNA replication, and in the form of the replosome for the RNA as compared to the DNA, right? Because the replosome, again, is just referring, to the best of my understanding, to the process of replication. I mean, it would be like walking out to my garage, to my Honda CRV, and saying, well, this thing has an engine and this thing has wheels. So the only way that you could get a car, the only way you could get a Honda CRV is if someone invented the engine and the wheel at the same time. But we know that cars today are the product of a lot of blueprints and tweaking, a lot of descent with modification, if you will, going all the way back to when the first wheel was attached to the first box and called a cart, right? And that cart functioned just fine as something that you could sit in and roll around and move a little bit in. Is it as advanced as a modern day Honda CRV? No, of course not. But these precursors exist from, through automobile evolution, if you will, and each one is useful in and of its own right. The same is true within evolution, whether we're talking about the origination of modern day DNA replication and DNA as a molecule, whether we're talking about, the sexes in mammals, or whether we're talking about the skeletal system and the cardiovascular system, right? Like these two things, that's not how evolution works. It doesn't expect that these two things are going to emerge, ex nihilo at the same time. There's always precursors. And, if you have a problem with the precursors, like, oh, well, we haven't figured out the details on how you get, replication in RNA. I'm fine with you saying that we don't have like an explanation for it at present, but not having an explanation for it doesn't mean that the hypothesis should be thrown out or that it's been precluded or falsified, because that's typically how science works.
Yeah, I understand that, and that makes sense to me. One thing I do want to ask you both is, when you gave me the analogy earlier of the crime scene and all that, and narrowing down the suspects, for you guys, is one of those suspects God? Or is that not one of your suspects? And you guys are
the
doing
thing
research?
is,
yeah, I think
Go ahead,
me and Aaron are going to have, we're going to have different answers to this. And I think that's fine. Because like, for me, the way that works is that it's like, for me, everything's on the table for answering, a lot of these big questions. I don't mind entertaining the idea that, God or some other deity could have like sparked life on Earth. I don't have a problem with that. I don't see any evidence for it, but I don't have a problem with it conceptually speaking. But I think the real issue is that when you're talking about something like abiogenesis, or when you're talking about complex evolutionary processes, and theists want to appeal to, well, it has to be directed, or God had to be the one that sparked it. My issue, God's getting mad. You can hear the thunder in the background. I think the problem that I have with that is that it's completely non-falsifiable and impossible to investigate using science. Right? Like, I would assume that you and I would both agree that God is conceptually, at the very least, supernatural, which means you can't investigate God with natural means. You can't use the scientific method on them. So at least as far as I'm concerned, if God is responsible for it, you're not going to find that answer in science. You're going to have to look somewhere else. Aaron, what are your thoughts?
So if we're going to impose the God idea, then we have to take all the baggage that comes along with this and all the things that you might expect. So if it's the case that we're going to basically have God come in and say he is the creator, then we have to explain not just the similarities between creatures, but the differences. Why do they seem to form these amazing trees that evolution itself explains extremely well? Why as I think it was Darwin who put it, the ornate fondness for beetles, the millions of species of just that subcategory of creepy crawly. The multiple attempts at humans, of which only a couple of species have decided to stick around and make YouTube videos. That's obviously a little bit weird. And also, if we're going to say, like, well, God has to be coming in and, like, driving all these forces, is like, does that mean also God is coming in and, like, driving the forces to make new superviruses and things like that? Did God create HIV? I bring up that example in particular because I remember Michael Behe, the somewhat inventor of irreducible complexity, said that he found irreducible complex things in the HIV virus, implying God made HIV. Well, that's a little bit, that's a lot of baggage to bring into your hypothesis. It's like God comes in, creates everything down to the tiniest molecular level, and also creates superbugs, and of course, also millions of years of species that have come and gone. These all look extremely hard to believe that this is what you would expect from a design, that you would not expect basically all of the drafts throughout millions of years of history. But on the other hand, using observable mechanisms of mutation And selection, it's like, oh, wow, we can actually explain a whole lot with something that we can actually observe in the here and now. And we can go out and test it and see in very particular ways, hey, there should be some common ancestor of all tetrapods. I bet it's in Canada. And we think it's in Canada because of doing a whole lot of good geology and biology. And lo and behold, somebody finds something and then decides to call it Tiktaalik to make sure that Westerners like me can't pronounce it correctly. Most importantly, one hypothesis has been just knocking out of the park, making predictions and living up to the best of science. And the other one is we'll explain it for this one thing and make excuses for why it doesn't explain anything else that we might expect. And to me, that's the biggest problem with the God hypothesis. It is so big and flexible that there's nothing it couldn't explain, because you could always just say that's God's will and it's inscrutable. It is beyond your understanding, which is literally to say you don't even understand what you're talking about when you invoke that sort of God hypothesis. If you have a God hypothesis where you think you know what God would do, that means you understand the mind of God. So either God has to be lower, or you are so full of yourself thinking you actually know that much. Either way, it's questionable theology, and it hasn't been successful science either.
Well, it sounds like you both, are open to the idea that possibly God is a suspect, although there's a lot of baggage, like you said, that for you would have to be cleared up before you get across the finish line. I just want to say I appreciate that y'all responded that way. The other thing is, you covered a lot there. Of course, I don't agree with a lot of it, but I will say, one other thing before, just on the RNA thing, before if we move on, or if y'all want to end it here, that's fine. But with RNA, it really needs an organism to keep it safe. Like RNA outside of an organism is very unstable. It degrades very quickly, has a very short lifespan. And so you really have to have an organism to protect it. And so that's probably my biggest issue with the RNA proposal, is that you don't have that, because there is no,
I happen to know,
no organism.
With my extremely limited knowledge of these things, I know that we don't need an organism, because what you basically need is a cell wall, or cell membrane, I should say more correctly.
A lipid bilayer.
Yes, which forms spontaneously. You can actually see that if you pour oil on water, it balls up. Fundamentally, that's the same thing that's happening with the lipid bilayers of cell membranes. They form spontaneously. They don't need any outside guidance other than electromagnetic forces between molecules. It's fairly straightforward chemistry in that case. Not even chemistry in some ways. There's no chemical reaction per se.
For me, right? I mean, like we know that amino acids are not uncommon, right? We find amino acids. Gosh, we find them in meteorites. Am I wrong on that, Aaron? I mean, we find them all. They're everywhere. And amino acids are really or rather nucleic acids. I think we find both, actually. Whatever, it doesn't matter. The point is that these biomolecules are like, they litter the earth, and they've been around for quite some time. Before life, you have organic molecules. It's just biochemistry, right? But I don't think it's a very far stretch to imagine these environments that are proposed for the earliest life forms that are like, again, hydrothermal vents, or these warm little ponds, like whichever one is your favorite. And we know, as Dr. Adair just said, that like these lipid bilayers, they form naturally, and they form like in the absence of life. Like they happen, right? Fatty organic molecules exist, and they form these little balls that can encapsulate things inside of them, sort of protecting them from the environment. So I don't think that it's a very far stretch, and I'll be the first one to say, like, we don't know the details of it, but I don't think it's that far of a stretch to see these types of environments where the biomolecules that you need for RNA are present, and the biomolecules that you need for lipid bilayers are present, and there are trillions and trillions and trillions of them interacting all the time, that in one of those trillions of trials, you're going to get some not RNA molecules. You're going to get some basic biomolecules like caught up inside of these basic cell membranes, right? They're super basic cell membranes. We're talking about a protocell here. It's basically just a cell membrane with some what is effectively like proto-RNA inside. But like, I just don't think. In fact, I would even propose that given just the sheer number of these biomolecules that we find in the environments now, again, I would propose the only reason that we don't see life emerge these days is because it's just going to, even if it happened, it would just immediately be outcompeted by all of these long established lineages that are really fine-tuned by natural selection and mutation over 3.8 billion years. But I don't think that it would be that far of a cry to suggest that one of those trillions and trillions and trillions of protocells is going to end up cementing itself, right? Like I just don't. To me, that doesn't seem. It almost feels like a law of large numbers. But again, like the question isn't completely solved. But I think it's a far cry from impossible or even improbable.
And very quickly, I looked online, and yes, we actually have found amino acids not just in meteorites, but in interstellar space.
Okay, that's what I thought, but I wasn't sure because I'm not an astronomer. I'm going to check on the nucleic acids too.
My biggest issue with that whole thing is that without DNA, there's no mind behind it. There's no code behind it. It would be like emptying a Scrabble box on a table, and you can kind of see maybe like somewhere where it might say dog or it might say cat, but you're never going to get, like a 150 character tweet out of that. It doesn't matter how many times you empty that box. You can do it 1 billion times. It just isn't going to form a coherent sentence, by itself.
Have you,
that's
Stevie? Have you ever
how I
heard
see
of
it.
Richard Have you ever heard of Richard Dawkins' famous like methinks it's like a weasel example? Is the little experiment that he ran where he took it was like code for linguistics, right? It was like code, a bunch of code that he basically said, I want to go from this random string of letters to methinks it's like a weasel. I don't know why he picked that phrase. I don't know why that meant something to Dawkins, but he picked it. And basically the idea is you generate this random string of letters, and when any of the letters are in the right place, as it would be for methinks it's like a weasel, it sticks around. And then you get mutations again, and then whichever ones in the next set of letters are in the right place, it sticks around. And I think it took someone in the comments is going to remember this. It took something like 32 iterations or 32 generations to get methinks it's like a weasel from completely random letters. So the problem isn't, you're talking about this Scrabble pieces being spilled out on the board. Yes, by totally random chance, the odds of you getting anything meaningful is going to be really slim. You're never going to get a 150 character tweet from that. But as soon as selection is at play, you can get any word on the planet. You can get any sentence on the planet, right? Selection is the name of the game when it comes to evolution, and it's the name of the game even when it comes to abiogenesis, like going from these very, very early stages to more complex stages. The idea is basically just like if it works, it sticks around, and if it doesn't, it doesn't. So from your Scrabble example, like I said, if you decided that you had this tweet beforehand and you were like, I'm going to pour the Scrabble pieces out, 150 characters, 150 little Scrabble pieces out onto the ground. And if it has any of the characters in the right spot, as for the tweet that you're going for, it gets to stay. And if it doesn't, then I take the remaining pieces, put them back in the bag, shake it up, and do it again. Right? That's how evolution is working over time to generate these super complex systems. And in fact, the difference between evolution and special creation here makes very separate. They propose very separate things. Whereas from an evolutionary perspective, even when you get these incredibly complex systems, they should still mess up all the time. They should be very rigged. They should be very held together with duct tape and zip ties. And they should be able to accomplish these complex tasks, but sort of in a way that it's it could definitely be more efficient. From a special creation side of things, these nano machines, that these molecular machines you're proposing should work, and they should work really, really well, and they shouldn't be super redundant. Now, if you ask a biochemist or a biologist which of those two scenarios we see when we look at the genome, they're going to tell you it's the former, right? I mean, DNA is incredibly redundant, and it messes up all the time. I mean, that's where variation comes from. So it ends up being kind of a feature, not a bug, at least with regard to life. But generating complexity is not hard so long as random mutation or probabilistic mutation is paired with natural selection. That's the big piece that, and it's not just you, a lot of creationists and a lot of my students, that's a concept that's hard to sort of to sink in. Does that make sense?
It does, but like I said, I feel in some aspects that it's a reach. Like your example about, pouring the Scrabble out, and then when you see, a word, then you could put, keep that word there. I think that works with your intelligent mind. behind it. You know what I mean? So that having that intelligent mind, I think, is really important. But I do find it a little bit of a reach without that. Now, there was something else I was going
Well, do you
to
think,
get
though,
at.
that it's the case that if you change an organism, it could be more or less adapted to its environment and be more or less successful reproducing?
I'm sorry, you cut out. Can you repeat the question?
Sure. Okay. Do you think it's at least possible that an organism has some sort of change that makes it more or less successful in its environment and able to reproduce?
Yeah, within limitations. Yeah, absolutely. I would agree with that.
Okay. Well,
One thing I
we'll
did want
skip
to.
the
Oh, go ahead. I
limitations
didn't.
part, but based on just that, that is natural selection. No mind required. Just that, hey, having this phenotype makes you more or less likely to survive and have offspring. That doesn't require intelligence at that point. It's just basically a weighted dice in that sort of sense.
Yeah, I mean, I actually agree with that. I agree with. I agree with the natural selection. That nothing with that is off about me. I think on the molecular level, it's not the same, but as it is later on. But I remember, Erica, you'd mentioned how DNA messes things up. Was that kind of a hint at the fact that there are mistakes, that hints at a bad design and therefore not God? Is that what you were kind of hinting at? That argument?
It's less that it's less that it's because it makes mistakes that it's not God, and more in the sense that these repair mechanisms are imperfect. That's more what I'm getting at. So it's not the fact, because I can see the appeal of redundancy, because redundant DNA protects DNA, it protects organisms from lethal mutations, because you usually have lots of copies of things. So it's like, well, if you get a mutation in this section, it's not going to actually harm the organism. So like I can see the design argument for that. But the problem for me is that DNA polymerase, I think it's DNA polymerase that does the repair, it's imperfect in its repair, right? It misses things all the time that it ostensibly should catch, I would propose, if it was specially created.
Yeah, I mean, I don't know if you guys have read the Bible. I do believe the God of the Bible, and the story is that the world was made actually was perfect. And after the fall, after Adam and Eve, the God cursed the world. And so to answer your question
The problem
earlier
with that,
about.
though, is if you're going to go that route, you either have to be a young Earth creationist, or you're going to have a lot more difficult things to explain. Because if you're going to accept the scientific evidence for the absurd antiquity of the Earth and the universe, you will find, hey, there have been creatures living and dying for millions and millions of years before the first hominid, let alone the first human. So it's pretty hard to explain an
I
imperfection due to human choice if we've had a billion years of nature redded tooth and claw.
I'm also pretty
I agree with
familiar with
you.
the genetic entropy arguments. That this argument comes that the fall is responsible for genetic degradation. This is like a John Sanford style argument. The problem with genetic entropy is that it isn't supported. Right? Genetic entropy is not something that we observe when we look at genomes. We don't see that at play anywhere, and we know this because we've sequenced ancient DNA. We've sequenced DNA using pedigrees of families going back generations. We sequence countless genomes of countless organisms, and they fit within these phylogenetic trees. They do not seem to show degradation, and furthermore, we see the emergence of like new information as we're observing these as well. So we could get into the problems with genetic entropy, including the idea that it involves redefining what fitness and what evolution is from the creationist side. But I don't know that that's a rabbit trail that we can go down it if we want, I guess I should say.
Well, just to answer his question earlier about the Bible and everything, I am a young Earth creationist. I agree with you. If you're going to defend the Bible, you really have to be a young Earth creationist. The other thing is, um, he asked about AIDS, or I think it was AIDS or HIV virus. Did God make that? Yes, He did. Um, and then you had mentioned. I know what I was going to ask you. So why is it that we don't let people, like? Why is incest not okay? Like, what does incest do to the genome?
So okay, I want to answer that, but I want to back it up. You said you were a young Earth creationist, right?
That's correct.
Okay, so you got a lot bigger problems than talking about like how do you than irreducible complexity, right? Like from your perspective, the model that, and I don't know which young Earth creationist model you hold to because there are many, right? But what I can tell you is that no young Earth creationist model actually can explain where biodiversity comes from. There are imminent problems no matter how you spin it, no matter whether you're going with a baraminological approach and saying that God has the archetypal kinds in the garden and then Noah takes archetypal kinds on the ark. There's a massive pressure from both directions as to how you have enough time for these organisms to diverge from one another after the ark lands on Mount Ararat without having too many organisms to actually fit onto the boat. Not to mention all the food that they need to eat and all of the space that they actually need and what you're going to do with the defecation. Like there's countless issues there. I mean, you could talk a lot about the model and logistical issues of young Earth creationism. And, you know, it kind of, to me, quibbling about abiogenesis when you are a young Earth creationist, I mean, to me, that's like quibbling about, I don't know, like a scratch on the side of your car when it's just been in a car accident. The data are robustly against that idea. Now, to this concept of incest, right? Incest is bad because incest causes issues within organisms, right? Like it increases homozygosity within the genomes of organisms, which can lead to the amplification of rare, deleterious genetic characteristics or genes. That's why incest is bad from a biological standpoint. It's also bad from a social standpoint. So social species do not do well with these kinds of interactions. So it ends up being, just from a brute utilitarian standpoint, not good, which is why, incidentally, organisms know not to try to reproduce with close relatives. If they're in social organisms, they just don't do it. There's a strong selective mechanism against incest because like there's such a massive biological downside to it.
Yeah, I find that interesting, that they know that. The other thing is, if you start with two people, then that's a concern, you know what I mean? So, but no, what you said, I think, I started with abiogenesis because that's the beginning. And without abiogenesis, you can't have even evolution, nothing. So that's why I started there. I'm open to
So,
any topic, really, but
yeah, so
I
Stevie,
started with that one for that reason.
I totally get that, but I've also heard that from creationists before as well, that it's like, oh, well, in order to appeal to evolution or to accept evolution or to even investigate evolution, you have to be able to show abiogenesis. First of all, that does not help you guys at all with the age of the Earth. And the age of the Earth is robustly supported to be 4.5 billion years of age. In fact, there's actually just no way to get all of the data from geology in general, whether you're talking about speleothems or continental drift or varves. You cannot get them to converge on this young Earth idea. It's impossible to do. Radiometric dating alone is problematic, but the fact that it's corroborated by all of these other independent mechanisms creates an enormous issue for the young Earth aspect of things. But to take things back to what Dr. Adair was saying earlier, I mean, like you can do a forensics analogy for this too. To say that you have to explain abiogenesis to investigate evolution is like saying that you have to know where a knife was manufactured in order to place it at a crime scene, which is just absurd. We don't function that way in any area of science or human inquiry, period, where you have to know the entire history of it to investigate any portion of it. And in fact, it's often counterproductive to any type of investigation. So, again, abiogenesis is a fine topic, and I'm okay to discuss it, and I'm okay to say that we don't have an answer too. But to say that you have to have that answer to investigate evolution, which evolutionary theory is the foundation of all of modern biology, generally.
Erika,
Go ahead, sorry.
I didn't.
Yeah.
I didn't say that. I just said I started with that. I'm not saying that we have to know that answer to move on to
Okay.
evolution.
Yeah.
I just said that you can't have evolution without, obviously, like if we didn't have life, then there's just no evolution, right? You agree with that? That's all I was trying to say.
Yeah, sure, but God could spark life, and that doesn't make evolution any less true.
Yeah, I mean, I think that there's just not enough evidence for evolution to be true. I think there's, like I said, you covered a lot of topics there that I have a lot to say on a lot of those. But we could go in whatever direction you want to go. Up to you.
Well, I do
Well,
think,
what's your
though, our call has gone a bit long, and we do have to get to other callers, though. And our producer has been noting that
dang it?
we need to be kind to the other people waiting in the queue.
Shoot. Stevie, why didn't you
Okay,
start
cool.
with
Well,
evolution instead of abiogenesis? That's what I'm actually formally trained in, and I could have given you great answers
I
to
would
all of
love
that
to talk
instead
to you
of
more, Erica. I would. I think
Tony.
we do need a new generation of creationist debaters out there. But yeah, I would love to talk to you more. I mean, maybe next time you're on, I'll chime back in
Call
and we
back.
can have a deeper conversation. Yeah, for
Yes,
sure.
I'm
This was
on once
fun.
a month at least on SkepTalk. Call back and we'll discuss more. And if you want to listen to some evolutionary stuff, we have some other calls on evolution. So please listen in and call back next time I'm on. Thank you for your time,
Okay, cool.
Stevie.
Yeah, I want to be respectful for everybody. All right, thanks you guys. Great conversation.
Thank you.
All right, bye-bye.
Good night.
Bye.
Hello, I'm Jimmy Snow, Pokemon Master and Executive Producer on The Line. Would you like to support a specific show on The Line or The Line in general? There are special tiers on our Patreon and in our channel memberships. You can do just that. By the way, you could consider leaving a super thanks down below. You could also like, subscribe, and leave a regular comment. All of these are great. Now, I'm going to get back to crushing loneliness, but while I do that, why don't you check out one of these?